How does PWM regulate electric motor speed? Imagine turning a light switch on and off very quickly to control how bright a bulb appears. That's similar to how pulse width modulation works for controlling motor speed. Pulse width modulation, or PWM, is a technique used in electrical engineering to manage how fast an electric motor spins. It works by switching the power supply on and off rapidly. The key idea is the duty cycle, which is the percentage of time the power is on during each cycle. If the power is on half the time and off half the time, that's a 50% duty cycle. If it's on for a quarter of the time and off for 3/4, that's a 25% duty cycle. In motor control, a PWM controller creates a square wave signal at a fixed frequency but with a variable duty cycle. When the signal is high, the motor gets full voltage. When it's low, no voltage is supplied. Because the switching happens thousands of times each second, the motor doesn't notice the individual pulses. Instead, it responds to the average voltage it receives over time. This method allows for smooth changes in motor speed without wasting energy. Unlike using resistors to slow the motor, which produces heat, PWM switches the power fully on or off, making it very efficient. When the switch is fully on, the motor gets full power. When it's off, it gets none. By adjusting the duty cycle, you can make the motor spin faster or slower. In embedded systems, microcontrollers or specialized motor driver integrated circuits generate these PWM signals. They can change the duty cycle based on sensor feedback or user commands, creating a closed-loop system. This is useful in robotics, electric vehicles, and conveyor belts, where precise speed control is needed. The frequency of the PWM signal is important. If it's too low, the motor might vibrate or make noise. If it's too high, the switching electronics might waste more energy. Usually, frequencies range from a few hundred hertz to tens of kilohertz, depending on the motor and application. PWM isn't just for direct current motors. It's also used in controlling alternating current motors through variable frequency drives. These devices convert direct current into a variable frequency, variable voltage alternating current waveform, allowing precise control over motor speed and torque. So, in simple terms, PWM controls how fast a motor spins by changing the average voltage it receives. It does this by turning the power on and off very quickly, making the motor respond smoothly and efficiently. This method is widely used because it saves energy, provides accurate control, and works well for many types of motors in electronics and embedded systems.